Good morning, everyone. My name is Paula Schönach, and on behalf of the Aalto sustainability team, it is my pleasure to welcome you to our today's session of Aalto sustainability talks. And I have also the pleasure to hand over the chairing of the session to Professor Minna Halme. She's Professor of Sustainability Management at the School of Business at Aalto University. So Minna, are you ready?
Thank you, Paula, and good morning to everyone. It is my great pleasure to welcome you to this fifth session of Aalto Sustainability Talks. We started this last fall, and now it's our turn to look at textiles, and we are under the SDG 12, Sustainable Production and Consumption this time, because the talks seminar series runs on different SDGs. This time we have three eminent speakers. The first two ones are from Aalto School of Chemical Engineering, Professors Herbert Sixta and Michael Hummel from the Department of Bioproducts and Biosystems at Aalto Chem. Herbert Sixta is a distinguished professor on cellulose chemistry, and on the side of material sciences, his special focus is on the development of high value-added cellulose materials regenerating from ionic liquid solutions. And Professor Hummel, together with Professor Sixta and other researchers naturally, have developed a fiber spinning process, which is now famously called the Ionsell. Professor Sixta and Hummel will have a joint talk. Professor Sixta starts and then Professor Hummel continues, and it's on the challenges and possible solutions for sustainable textile fiber production. And then I'm also very proud to present Professor Pirjo Kääriäinen, whose special area is design and materialities. She is from the School of Arts, from the Department of Design. Pirjo Kääriäinen is what I would call a pioneer in interdisciplinary work between arts, design, and chemistry, centering around the development of new concepts for sustainable use of plant-based and regenerated materials. And Pirjo will be speaking about the fascinating future of textiles. And we'll indeed proceed so that Professor Sixta and Hummel will speak in a row, and then we take questions to them afterwards. Then Professor Kääriäinen continues, and then we will have questions to her and continue to the panel discussion in the end. And now I'm happy to hand it over to you, Herbert. So please, the line is yours.
Yeah, thank you so much, Professor Minna Halme, for the kind introduction. I hope you can see my screen. Ladies and gentlemen, the textile industry is currently facing a lot of challenges, and I would like to share some ideas about possible solutions for sustainable textile fiber production in the future. More than 65% of the global textile fiber market is currently covered by synthetic fibers, with polyester and polyester filaments dominating by far. While the production of cotton fibers has stagnated for many years, both synthetic and cellulose regenerated fibers have recorded an average annual growth of close to 4%. In recent years, people have become increasingly aware of the negative environmental and societal impacts of the current textile industry. However, most of the efforts of the textile industry are focused on reducing the impact of the current linear system, keyword fast fashion, rather than addressing the cause of the system's wasteful nature directly. In my presentation, I will discuss the ambitions outlined in the very well-known Ellen MacArthur Foundation's report, and I would like to start with the first one, namely the elimination of substances of concern, and I focus on the microplastic emissions. Then I will continue with the pros and cons of the use of renewable resources, and finally I will give some examples how to improve the longevity of textiles. Now let's go back to the microplastic emissions and the possibilities to reduce them. You see here the well-known picture of Inomia, which has been published in 2016, and it shows the various sources of plastics in the aquatic environment. However, the macroplastics in the size of 5 microns to 5 millimeters are the ones who are of particular concern. Microplastics released from laundering of textiles accounts to about 20 to 35% of the approximately 1 million ton of primary microplastics. Most recent studies reveal what has been already suspected, that washing of cellulose-based textiles results in a higher release of microfibers compared to polyester. However, of course, due to the biodegradability, this does not really have an impact. But the lower release of polyester microplastic fibers can be partly at least attributed to a more dense surface structure and the predominant use of filaments in the use of polyester. Even though some of the wastewater treatment plants remove up to 98% of the microplastic fibers, it is considered that wastewater treatment plant effluents are still the major source of the microplastic fiber emissions to the aquatic environment. Yeah? So what further options do we have to minimize the emissions from microplastic fibers originating from synthetic fibers? So for example, filaments fiber, it's well known with high twist and low hairiness. So filament versus staple fiber, woven versus knitted has an advantage, and laser cut, even the cutting of the fabrics has a big impact, laser cut versus scissors cut. And just to give one example, the increase of the integrity of the surface, for example, by cross-linking. There is a nice example has been recently published of pectin, for example, on the surface of a polyamide fabric. I just show you the scheme of this reaction. And surprisingly, the authors conclude that more than 90% of the number of microplastic fibers has been reduced, so that we can safely assume that when appropriate measures are undertaken, that we can assume that in future, at least 90% of the current amount of microplastics can be reduced. So that's quite a good indication. Now, the big advantage of cellulose fibers over synthetic fibers is, of course, the very efficient biodegradation. And this is also generally accepted. However, what is the impact of dyes and finishing chemicals on the biodegradation of cotton fibers? In a quite comprehensive study, it was investigated, the biodegradation was investigated of cotton, which was treated with different textile finishes. It was a knitted fabric, and it was treated with a silicone softener, with a durable press to improve the dimensional stability, and fluorinated water repellent. And as a representative of the dye, the reactive blue dye shown here with this anthraquinone substructure. So what is actually the effect of this additives on the biodegradability of the cotton fabric? And using standardized biodegradation methods simulating the aquatic biodegradability, this question has been addressed. And to make a long story short, the authors summarize that basically all these additives have an impact on the biodegradability, but in the end, cotton fabric is completely biodegradable. What is changing is the dynamics of the biodegradability, not so much by the dye and the softener, but substantially by the durable press and the water repellent. So still, I would say the active compounds of these finishing formulations are, however, not biodegradable and are thus released to the surface waters. There was a nice picture after the degradation of the blue dyed cotton fabric. After the degradation, we saw the blue aqueous solution. So the message here is that it is very important to develop high quality, that's the point, biodegradable finishing chemicals and dyes. So that is a message also to the funding agencies. Now, I would like to move on to the next ambition, namely the pros and cons of the use of renewable resources. It's not automatically clear that the use of renewable resources results in sustainable textile fibers. Not at all. And the major example is very well known. It's cotton. Cotton growth contributes to extreme water scarcity. That's very well known. Else also the high amount of chemicals used, fertilizers, pesticides, herbicides, etc. So that is very well known. Less known is, and this is quite interesting, namely that also wool and silk has a big impact specifically, but on a global basis, it does not really have a big role. Why? Because the amounts of productions are quite minor. Now, coming to the pros, what kind of biopolymers might have a potential future? I have the assumption, and this is shared also by others, that within the next decades, wood will become more expensive, for example, due to its increasing competitive use in various areas, for example, construction industry. And in the following, I will highlight 3 examples of sustainable polymer of potential interest for the textile industry. The first one is Curdlan, which is an exopolysaccharide. It's a water insoluble. It's a beta-1,3 glucan. And the first results have been published where this polymer has been converted to a nice textile fiber using the dry jet wet spinning. More experience is already available with the conversion of this alpha-1,3 glucan. Lansing has a lot of experiences to DuPont, and different processes have been investigated, and the result is also quite promising. The textile properties are in an acceptable range. As a representative of the natural fibers, I highlight hemp fibers. Opposite to cotton, they are quite sustainable in the growth. And of course, hemp fibers will never replace cotton, that's clear. It will remain a niche product, but I suspect that a gradual increase in the coming years is possible. However, the most important biopolymer for textile fiber production in the past, in the present, and in future is, of course, cellulose. The only change is that, of course, there will be a shift from wood pulp, cotton linters, more to the wastes, to the textile, and also paper wastes, and to other sources I mentioned already. And of course, then the question arises, which sustainable processes for the manufacturing of textile fibers, staple fibers, filament fibers exist? As you know, the predominant process for the production of regenerated cellulose fibers is the viscose fibers. And even though there was a lot of efforts during the last 30 years to substantially reduce all the emissions, there is a remaining concern due to the use of carbon disulfide. Yeah? This is certainly a problem. It exerts some additional concerns. I would like to highlight the state-of-the-art viscose technology represented by Lenzing AG and Kelheim. They have cleaned up their sites, and also LCA studies confirm the high level of sustainability. Nevertheless, due to political and of course also societal pressure, there is a renaissance of older wet spinning process which have been basically developed during the last 30, 40, 50 years even. And I would like to highlight those because they have become a renaissance all above the carbamate process, which is currently heavily investigated also in Finland, and another group in China by around Lina Zhang. And of course, also there are other attempts, for example, in Germany. And now the focus is more on the recycling of the chemicals. There are really new, nice results available on that, and also the recycling of textile wastes. So the results are really promising. The second category of new wet spinning processes is basically based on the finding of a person called Sobue in 1939. Namely, he found that cellulose can be dissolved in caustic soda at certain conditions. And two companies, Trito Textile, a Swedish company, and Ionsell or Ionsell, have adopted this method. They added zinc oxide, for example, to improve the capability of dissolving cellulose and also other additives. And the novelty here is, and that's really nice, that they could replace the conventional coagulation bath now by a coagulation bath, which allows a very high recyclability of these chemicals. So this will be quite interesting also because an investment has been announced in a Swedish pulp mill, and it's really interesting to follow up what will happen. A very innovative and interesting is the spin-over process. Contrary to the others, cellulose is not dissolved. It is forming diluted aqueous suspensions. It is pumped through nozzles to form a filament, and a gel is formed by cross-linking chemicals, which then finally is formed to a solid filament. The results look really good, and also interesting is that already a commercial investment has been announced for 2022. So this is really very promising, and therefore I can move on now to the next and third important ambition, comprising the improving of the longevity of textiles through recycling, and also to improve the durability of the textile fibers. That means the properties, especially the mechanical properties, have to be improved. I will show you for each of those parameters one example from my laboratory. And the first one constitutes basically shows the advantage of chemical recycling or upcycling compared to mechanical recycling or downcycling using two different cotton roll towels. These investigations are currently run in a nice project which is ongoing, of course, but an intermediate result can be shown here. These roll towels have been converted by our Ionsell process to stable fibers. And I show you now the results in terms of stress strain behavior. Here you see as a reference the stress strain of a virgin cotton, not a recycled, a virgin cotton. And as a comparison, you see here the stress strain of the staple fibers prepared from this recycled roll towels. So you see a doubling of the tensile strength. This is really enormous. You see also here in this cross section, the typical lyocell type fiber. So this superior tenacity has been transferred also to the Ionsell yarns, where the mechanical properties have been tripled. So compared to the mechanical recycled yarn, the yarn produced from the Ionsell staple fibers originating from these roll towels is 3 times in terms of tenacity. This is really enormous and shows the potential of upcycling. And this holds true also for the blue roll towel in general. Of course, we have, also produced some fabrics out of that, and the first results are shown here. Now, the last example concerns the durability, the increase of durability, so that in future textile can be worn in a longer time and the quality is not deteriorated. So for that, I made the assumption that the durability of textile fibers is related, at least to some extent, to the intrinsic mechanical fiber properties. To make a long story short, I show you the outstanding properties of a typical polyester fiber compared to cellulose fibers. It is characterized by high tenacity combined with high extensibility. Therefore, it has a high modulus of toughness. That is really interesting. When you compare here the stress-strain curve from a regular viscose fiber, it's just about 1/3. And even the strongest commercial man-made cellulose fibers, the Cord-Enka Super Cord 3, comprises roughly 62% of the toughness of polyester fibers. The lyocell type fibers here represented by Ionsell has roughly 50%. And together with my PhD student, we worked hard during the last 2 years to gradually approach the properties of a polyester fiber. Of course, we are not yet there, but we succeeded with this Ionsell high toughness fiber with 94 megapascal, which is already quite nice. We could not only increase the tenacity or the modulus, but especially the extensibility. So that is the target, to improve the durability, and I'm pretty confident that we will continue approaching the target values. Now, ladies and gentlemen, I come to the end of my talk and also give some outlook, and I want to formulate 5 statements out of this. So I'm convinced that microplastic fiber emission or generation and emission can be significantly reduced by appropriate measures. I believe in the future of synthetic fibers. They have outstanding properties which otherwise are not easily attainable, not by silk, not by cellulose-based fibers. So they have special properties and we need to preserve them. And when you look at the life cycle analysis, they are way more sustainable than cotton. And also together with the complete recyclability of, for example, polyester fibers, and the fact that you can synthesize the monomers from sugars, for example, then this has really a good sustainability profile. Very important is the message here is there is an urgent need of high quality. There are a lot of biodegradable dyes and finishing chemicals. They are of low quality. They are not achieving the requested target quality. So we need high quality biodegradable dyes and finishing chemicals. I reviewed the potential of new wet spinning processes, and I think that they have a future to be commercialized, but, and the big but is they need to further develop and improve the properties of these fibers. So it's not enough to just attain the properties of viscose fibers. So that is would not justify new processes. And finally, I believe on the necessity of the chemical upcycling of textile wastes, and not only the upcycling, but also developing textile fibers with a high durability using renewable polymers. So ladies and gentlemen, thank you for your attention, and I'm happy to take questions after Michael's presentation. Thank you so much.
Thank you, Herbert, for your excellent presentation that I'm sure that has given new thoughts and new information for many of us. I would request the participants to write their questions in the chat according to the instructions that have been given. And now it's time to introduce to online Professor Michael Hummel, who will continue from here. So Michael, the line is yours. Welcome.
Thank you, Minna, and good morning, ladies and gentlemen. Also on my behalf, it's my pleasure to be here at the Aalto-Sustainability Talks and to have the opportunity to introduce the Ionsell process that Herbert has already mentioned in a little bit more detail to you. So this is what this talk will be about in the next couple of minutes. We'll focus a little bit on the development of the Ionsell process itself. I will explain a few spinning technologies to put this whole into perspective. And then we'll focus on textile recycling because I think this is one of the most pressing issues. This is the timeline of the Ionsell process. And if you look at the starting point, it started already in 2009. So it dates back quite a few years, when the goal was to develop a process that can convert wood pulp into high quality textile fibers. And as a matter of fact, a couple of initiatives started back then already, and Herbert has indicated a few of them already. We had a couple of milestones there. You see, it took us 2 years actually to install a functioning spinning machine, and then another 2, which seemed long years until we had the first successful spinning trial. And after that, it went relatively quickly. 2014 was a milestone because our first demo product with Marimekko really caused a lot of attention. Then in 2016, with the Global Change Award, we also got some international recognition. One highlight that I want to mention here is definitely the Independence Gown for the First Lady in 2018. And where we are now is trying to upscale everything. So now we are just in the startup phase of the Ionsell pilot plant to increase the production efficiency. So I said I will tell a little bit about spinning technologies to put this all into perspective. And the most common one is melt spinning. So in melt spinning, you have a meltable polymer, and then you extrude it into filaments. You have cool air flowing around these filaments, causing them to get solid again, and then you have your final fibers. That's a very efficient process. And polyester, for instance, is made this way, also polyethylene, polypropylene. So there are a couple of fibers that are made from this process. Another one is dry spinning. So in this case, you choose this technique because your polymer cannot be molten. When you heat it, it will actually start to decompose. So you seek a solvent that can dissolve this polymer, and then you spin it through a drying channel or a hot air channel. So you want your solvent to evaporate again, leaving back the solid fiber. And prominent examples for these fibers are acrylic fibers, for instance, but also elastan. Elastan that is also known as spandex or lycra, depending on the manufacturer. Then we have wet spinning, so still a technique where you have to dissolve your polymer, but now the solvent might not be easily evaporable, so you have to wash it away. And in this case, you put your spinneret directly into a so-called spin bath, where a solvent exchange takes place, causing the same thing that you want, namely to solidify your fibers, and then you collect them. And one of the most prominent examples for this is the viscose process that Herbert has already mentioned. And then, last but not least, there's a hybrid version where we have solution spinning, so we have to dissolve our polymer. We have a coagulation bath, but we also have a small air gap, so the nozzle is not directly in the coagulation bath, but we're going through an air gap. And this is actually the technology that Ionsell is based on. Here you see a picture of our biggest laboratory size unit in action. So the filaments are coming out. And if we look a little bit closer, what you can see is the spinning unit with the spin solution being in the cylinder and being extruded into the coagulation bath. And I mentioned already this air gap, and this air gap is very decisive because what it allows us is to stretch the still liquid filament and make it a lot thinner at the same time. So we do this by having a much higher so-called take-up velocity than a velocity with which we extrude our solution. Not only does this make our filament thinner, but it also creates high orientation of the polymer molecules. In solution, our cellulose, which is a linear molecule, so long chain, has so-called random formation. What we want these molecules is to align in fiber direction, because if they're aligned, they can interact very tightly with each other, and that makes the fiber very strong. A very famous example for these highly oriented fibers is Kevlar. So there you have high orientation, gives it extremely high strength, suitable for bulletproof vests, for instance. And I believe this is one of the central features that promoted Herbert back in 2009 to pursue this particular technology, because very few other technologies allow to create this high orientation in the structure. We need special solvents to dissolve cellulose. So cellulose cannot be molten. That is maybe known already, but less known is that there are very few solvents that are capable of dissolving cellulose. And these are two examples and two ionic liquids that we are using. So these solvents have been developed at the University of Helsinki, in particular by Professor Ilkka Kilpeläinen and Professor Alistair King. So what I show you here is again a stress-strain curve that Herbert has shown already. What you see here is that the force that we need to stretch a fiber. So we are gradually stretching the fiber, and we're recording the force that is needed to do so to cause this deformation until this curve ends, and that indicates the rupture of the fiber. And here you see that the white dotted line, Ionsell, is clearly superior to the other alternatives that are on the market now. So a regular tensile fiber or viscose fiber, and also cotton, you can see that cotton is a lot lower. On the right-hand side, you see electron microscopy images, where you can see not only the body of the fiber that Herbert has already mentioned, but also the cross-section. You see we have a very round, even cross-section, very smooth surface, and that is also advantageous for textile applications. Here are a couple of prototypes that we made over the years. I highlighted one of them already. But I think more intriguing than we can use wood pulp, so high-grade raw material, is that we can also use waste material. And here are some examples that have been researched in Herbert's group over the year. So you don't need to have virgin new material. You can use waste material like waste newspaper. You can also use waste cardboard that is shown here. So here, this beige color is actually coming from the cardboard. And probably most intriguing is that we can also recycle textiles, cellulose-based textiles. Here's one example on the right-hand side, in the lower corner, where we used hospital bed sheets to start with. Hospital bed sheets are 100% cotton. They're typically white. They have been laundered many times during their lifetime, so it was an easy start. And you could see we could make an easy product out of that. Herbert mentioned also other raw materials, cellulosic raw materials, and hemp is one of them. And obviously it doesn't make sense to use new hemp, dissolve it and spin it into fibers, but waste hemp, so garments that have been worn already, thrown away. And you can see here, you can dissolve them nicely. In a recent project by Susanna and Maria, where then they have created new Ionsell fibers, for Ionsell fabrics, based on hemp raw material. And what you can also see in these microscope images here is that an advantage is that we are kind of removing the inhomogeneities that are inherent for natural fibers. Now, converting white or colorless textiles is one thing, but what about if those textiles are colored? Because this is the majority what we have in our closets. And this is a nice project because this all started with a master thesis initiated by a student from the textile design department. And she went to the second-hand store, purchased different products that were made of cellulosic fibers, so viscose, stencil, cotton, and then she sorted them according to color, dissolved them and spun them into Ionsell fibers, which you can see here in the front. And you can see in some cases, we actually can translate the color quite nicely. And more than that, we can even create new colors by combining colors, as you can see here on the edges. Also from there, we could make a few demo products, so where the raw material for these completely here new products has been colored waste textiles. And so coming back, what we want to do is, of course, not only keep the dyes into the loop, but on the long run, we also want to shift to new dyes that are sourced from natural products and, more importantly, are also biodegradable, because there's always a risk that something ends up on the landfill and is not kept in the recycling loop. So what we're pursuing here is natural dyes from various sources and incorporate them into the fibers. So what are we doing next? I indicated already the pilot plant, which is currently run up. And that has, of course, the advantage that we can produce more fibers. To be more precise, we can produce 100 times more fibers than we used to in our lab. So now we have a daily capacity of approximately 10 kilograms per fiber. But more importantly is to make this process really commercial, we have to show that we can recycle the solvent. So these ionic liquids that I showed you. And this is only possible on a larger scale when you can really cycle and cycle over again to develop this process. And this is what the main focus will be for the coming years now. This is all I wanted to tell you about the Ionsell process today. Minna has already mentioned that it was not only her, but and me who was involved in this process. As a matter of fact, there were, I counted, more than 80 researchers, staff, and whatnot involved in this process, postdocs, PhD students, master thesis students. So more than 80 people only at Aalto University. And I think I managed to catch here a bit more than 60 of them. So I apologize for those who are not in the picture. And yeah, with this, I would like to thank you for your kind attention.
Thank you very much, Michael. This was very, very interesting, and especially, ending with this picture gallery showing that science is a collective way of knowing that we need a lot of people to develop the new solutions and great leaders like Professor Sixta and yourself. Now, I have one question so far in the chat, and that is by Aino-Maija Haarla. Aino-Maija, please do ask your question.
Hello, everybody. Thank you very much for the information in the previous presentations. Very interesting indeed. And actually, I have a question about the commercial status of the previously described processes. What is the most advanced, and is the existing textile industry involved with these very interesting projects already?
Nice to hear from you, dear Aino-Maija. This is Herbert speaking. Thank you for the questions. If you mean the Ionsell process, because this is where we can talk about, as Michael said, we are now starting the pilot plant phase, and quite unique for a pilot plant at that from this size. We try to synchronize not only the fiber line production, but the fiber line together with the recycling of the solvent. So the idea is to develop a continuous Ionsell process within the next 2 years, so that the necessary information could be available for a company to consider an investment. So that this is roughly our idea at the moment.
Okay.
Thank you.
When you are referring to the other processes I highlighted, these wet spinning processes, of course, I can give my opinion as a professor here, but I'm not really involved. I have been involved in my pioneer times at Lansing. I know, of course, those processes very well, but of course, I have no access to the real details of the current status of these processes.
But maybe, Herbert, if you give some indication as an expert anyway.
Yeah. The best sign is when these companies announce an investment, as I've shown you. So this Textile, they have announced the 35 million euros investment for quite big demo plant, so that is a good sign. The same also for, or even better, so the spin-over process is about to be commercialized. So this is really interesting and very, very nice information. So I would say, yes, they have reached a maturity level which allows to consider commercialization.
Thank you for the question and for the answer. Now I would like to hand it over to Roope Huskavel, who has a question to both Michael and Herbert, so you can decide who responds. Roope, I think our organizers have unmuted you, so you can ask.
Oh, hello, good morning, and thank you for the excellent presentations. I was just wondering if you could maybe provide a brief summary about the key benefits and maybe also challenges associated with sustainability and circularity of these innovations and processes. Just briefly, thank you.
Yeah, again, back to our Ionsell process. If I can start, this is Herbert. Nice to see you, Roope. Yeah, the target is to use only sustainable raw materials. Of course, we use natural polymers or also other biopolymers, as I mentioned. And the process has to be completely closed. So a closed loop operation so that we don't have any gases or water emission. That is the first prerequisite. Also, of course, we aim at minimizing the energy demand. This is a little bit tricky because if you use a closed system, then it might be necessary to use also higher temperatures, for example, but still this is a demand. And thirdly, of course, also not to be only closed in the process, but also closed regarding the product. So we now started a project to recycle our own product as many times as possible, so that we then really see how often we can recycle our own product. This is, I think, the biggest challenge now.
Thank you. Thank you for the question and for the response as well. I think we can continue from these questions also at the panel time. And now it is time to have Professor Pirjo Kääriäinen speaking about the future of sustainable textiles. And Pirjo will now broaden to more, let's say, toward the use and design and the, let's say, larger textile systems that we might see in the future. So Pirjo, please take the line.
Thank you, Minna. Okay, yes, thank you, Minna, and thanks for Herbert and Michael for these excellent presentations. I think now we jump a little bit more on the let's say experimental and futuristic field, and especially I'm looking at the things and talking about these things from designers and users' perspective. And what I definitely need to say, what is happening currently? I have a background in textile industry, and it's amazing to follow these things that are happening currently in a very grassroots level, but also, of course, in a big scale in the industry. And what I've been thinking that it is really time also to dream. At the same time, of course, like we have also heard through Herbert's and Michael's presentations, we need to really act and do things, develop things, and explore, experiment, and fail. There's a huge amount of experimental, even, I mean, very kind of, let's say, do-it-yourself scale things happening currently related to these materials and material futures. And of course, that they might not be the ones that will transform the industry, but I see them as a very important tool to change our approaches, our attitudes, and our thoughts. I have in my mind 5 different aspects that I want to open up a little bit, and from the user's perspective. And in a way, I kind of hope that these are the things that we'll keep on discussing in the future. Some of them we do already now. Maybe these are some discussion topics for the future. Maybe in 10 years, we don't only discuss the things that we are eating, which is very popular now, what kind of diets we have, what kind of nutrition we are taking in, but also to know more about materials and the whole material world, how it functions now, because that is something that we need to, that kind of knowledge we need to have to be able to make these changes. And as already very nicely explained in Herbert's presentation about these recycling issues, we already see these things happening. Of course, it's about reuse. It's about having better quality items, kind of investing in these garments, for example. That's how our grandparents used to do it. They were big investments which were loved and taken care for. It's interesting to see that there are many small companies already working with this kind of recycling, mechanical recycling or reuse and repairing. And also here in the middle, it's the concept that H&M has been promoting, kind of that you can take something in a small, almost in a shop, and then take your old garment there, and it could be produced to a new garment, and you can follow how it happens. Also, we have plenty of students at Aalto University who really love to experiment. The generation who is studying now is super interested and worried on these issues. And there are plenty of experiments going on. For example, here, one of our textile fashion design students was experimenting how to use this kind of waste materials for paddings. Also mentioned was already this use of hemp. And in general, this kind of local materials and locally sourced materials, whether they are waste or even something that can be grown through agriculture, it's time to look back a little bit. Of course, hemp has been used as a raw material already for maybe thousands of years. Also linen, nettle, also natural colors have been there as a main way to dye fabrics and textiles. We have been using wool a long time, but now it's also time to rethink and refine these things, maybe by using the new technologies which are available, and to reconsider how these traditional materials can be used in a new way. And for example, here in the middle, it's super interesting research going on also related to this wool, how it could be used, how we have lost during these previous 150 years with this, or 200 years with this industrial revolution, how we have lost maybe some interesting functionalities which these materials used to have before they had been developed towards our industrial processes. Transparency in general is a topic that really is for the future. So we need to know where things come from, how they are produced, and where they will go after we have discarded them. It's also super interesting to follow what is happening in this very do-it-yourself level, and there's so much enthusiasm now towards growing of things, growing of materials, growing of using mycelium, this kind of fungal materials, or microbial cellulose, kombucha, and students are experimenting with and plenty of a huge community around the globe, designers and enthusiasts are now working with these kind of aspects, experimenting if we could have a future where these materials could be grown, even at home. It's also about, you know, most of the people are aware of brewing of beer or alcohol, or using this kind of fermentation, which is super popular now in food production. And but of course, this kind of a technology, I'm an expert in technology, but this kind of technologies are now used to also to produce materials with new technologies. And I just love this image on the right side. So I've been working a lot at the textile factories, but in the past, but maybe the future factories might look also like this. This is about a brewed protein by fiber company. Experiments are going on, and many of us we see plenty of these prototypes and fancy photos in the media currently, but of course they are the first experiments and not yet very far away from the real applications. Yes, and of course, as already Herbert mentioned, the issue of all these finishings and dyeing, that's a big topic, very hot topic and very important topic in textile industry, and the discussion, for example, by using microorganisms to dye textiles. It's really researched also quite widely now. Maybe we can even use these biological processes to produce the colors. Here in the middle, we have these colors by photosynthesis, like the same mechanisms that the tree leaves of the trees are working. But of course, these are living ones, so they would require some nutrition. And then we are now opening up the huge area of synthetic biology. So in addition to learning from the nature and the biological processes, the huge spectrum of synthetic biology is opening up, including genetic engineering. And for example, here the glowing dress, it's from one artist art exhibition, in fact, from New York. But the silk dress was glowing, and it was due to this transgenic approach that had been done when the silk worms started to develop. Well, all these projects and many more, all of them have been inspired by the idea of sustainability and sustainable material future. But it is extremely huge question mark. We don't know yet at all which ones of these first ideas or even a little bit more developed ideas are truly sustainable. And many of them might not be realistic. And at this stage, we have quite a big problem even in the commerce side, because we have so many more questions than answers. And it's extremely important that we also try to open up to the users who are kind of waiting for more sustainable products to be available. We need to open up what is the situation, how these things are developing, and how long these processes are. As Michael was explaining here, it might be 15, 20 years before we have these things available in our everyday lives. But anyhow, we need to dream, we need to dare to dream, and of course we need to do things, work and act to achieve those dreams. So thank you.
Thank you, Pirjo. And indeed, thank you for opening up our topic to the wider future opportunities and developments area. And now there is one question in the chat from Jaakko Viitala to Michael, and we will take that next. And let me just say now that
we open the panel discussion now. So our 3 speakers are now available to you, and you can either ask questions that are directed to all of them. You can also ask questions that are directed to Pirjo or to either one of the other presenters. But let me now give the speech to Jaakko Viitala.
Yes, hello. I hope you can hear me fine. I'm working at Emmi, and as our whole business idea is built on this circular economy model, the discussions today have been very fruitful and interesting. Thank you for that. As a Finnish market leader in turnkey second-hand fashion marketplace, collecting the data of used garments is a strong part of what we do. So my question to Mihail is, I'm aware that there are spectrum analysis methods for identifying materials, but I don't know that too well. So do you know what methods there are available, and if there's applications for identifying the raw material of a garment and also the condition of that material?
Yeah, Jaakko, that's exactly one of the most critical questions when it comes to textile recycling. How to identify what you are actually getting back. And to my understanding, this is still one of the bottlenecks. Because there are a lot of methods that you can use to analyze it in very detail. But what you want is a method that is extremely fast and has a high throughput to be able to handle all this. I think Germany is very strong in this. There are a couple of companies working on this. And as far as I know, infrared, or to be more precise, near infrared is one. So the garment is going quickly through a machine, the infrared is scanning it and can detect the approximate composition. The downside is that garments are unlike a t-shirt where you have one layer, you might have multiple layers. And then these methods, they typically can only detect either the surface or the layer that is exposed to the ray. And that is really a critical question. I don't know, Herbert, maybe you know of more initiatives for screening of waste textiles?
Yeah, actually, very good question, by the way, Jaakko. Within the Phoenix project, which is headed by Minna, we investigate so-called hyperspectral imaging together with VTT. And so far we can, of course, distinguish easily between natural fibers and synthetic fibers. That's not really very difficult. But now the next idea is to distinguish between different cellulose-based fibers, so viscose, Ionsell, and natural fibers. So this is also quite promising, by the way. So there will be methods, but as Michael said, the problem is sometimes you have different system layers and mixtures, which is very difficult then to quantify and to differentiate within that. So therefore, there is one initiative to have this mono-material textile. So this is what my favorite, not to mix everything together. But of course, then the requirements on single textile fibers is extremely high. Very good question. Thank you.
Yeah, and if I may just very quickly add, Jaakko, in addition to what was now mentioned in the Phoenix project, which is FINIX, an aalto and others large project, you can check the website later on, but a Polytechnic from Lahti, the lab, University of Applied Sciences, they are developing a more rudimentary quick technology for checking quite quickly the basics from a garment. So it's already something that you can, it's a portable option where I could kind of come to you and sort of, screen your hoodie and see what it contains. But you can check the website and then you will find out a bit more there. Great. So let's see now. There are also some other further suggestions on this particular question. And let me see. Aino-Maija is also having a question to Pirjo. So Aino-Maija, you will be unmuted again now, and you can ask the question.
Thank you, Pirjo, for the very inspiring presentation indeed. So there happens a lot when you keep your minds open and eyes open as well. I have a question regarding the dyes, natural dyes available in Finland, like morsinko. Could you give a quick overview on availability of these natural dye materials in Finland, very briefly?
Okay, thanks, Aino-Maija. Of course, there's a very interesting research project going on now, biocolor.
Okay.
So that would be some worth to follow, and I think they are also having a very nice, an interesting seminar coming in coming days. So check that, and we have plenty of ingredients that could be used for dyeing as such, for natural dyes. But of course, when we take anything from the nature, we need to be very careful. So if we think of the bigger quantities, so it might be that we really need to find new ways to produce those the dye stuff, in fact. So either through cultivation, like this värimorsinko, natural indigo, that can be grown in Finland as well, and others. So we need to develop these methods. And this bacterial dyeing, in fact, how to really extract these ingredients from bacteria, for example, that's really developing fast now, and there are plenty of already research going on around the globe. And that's what I think, that as so many things happen now, I'm pretty sure that some of them will come later on, can be scaled up and change the industry.
I would actually, thank you for the very good question, and I would actually like to continue with that, asking about this, let's say, the new fashion of colors. And this relates to what Mihail was saying in his presentation, that you can actually get the colors when you recycle the fabrics. You can also get the colors to kind of, come along, at least in some cases, but they will not be the same shades of colors that we currently mostly have. And as I would see it, in the future, maybe, and you can take a stand on it, could we have this kind of like an indication of you being a sustainable person, is that you are actually wearing clothes which has colors that is indicating that the material is coming from a recycling process. What do you think of this kind of changing the fashion of colors?
Yeah, that's a very, very important point, because this kind of approaches will change how the things are designed, how the collections are made, and all these cyclic things that we have used. We have had, for example, we have a trend color for the season and so on. But it would change if we get the colors directly from the recycled materials. It would mean that we have a certain punch. We have a punch of a certain color, and we need to accept variations for example, inside a collection. And of course, in many cases, the natural dyes, as they are nowadays, they are, for example, reacting to UV light, so they are fading. So that would be another approach that maybe it would require a completely different attitude towards these things, that, okay, these things are fading now, the color is going off, it's not plain enough. So it would require a change in the mindset, the different kinds of implications that would have to users, to industry, to business. Very interesting question.
Yes, and now I would like to open the discussion toward, let's say, a wider sustainability question, also relating to our use of any products, but also textiles. We have now been discussing quite a lot about the natural materials, and we've been discussing about recycled materials. Herbert has referred to the tenacity, the durability of the fibers that come from the recycling processes. But I think that one of the big questions is really that that is this like continuous circularity the answer, or should we also seriously consider of using our textiles, including clothing, much longer times, and develop the businesses around that, instead of thinking that the circulation continuously solves the problem for good, so to say. And here I would like to hear all panelists' views on what you think of this issue. Herbert, you are muted.
Yeah, this is the ultimate question. Thank you, Mina. I can, of course, give only the answer from the chemistry point of view. Of course, the fashion type relationship is quite difficult to predict. I don't know. So who would have predicted fast fashion 50 years ago? So, but for example, my point was to keep garments in a longer loop requires a higher quality textile fiber, unless you manage to, yeah, I think that this is a prerequisite. Otherwise, when the quality of the garment changes, gets worse, then of course there is the request to renew it, and therefore one option is to improve the quality of the textile fibers. At least that is what we can provide, or what we want to provide. If this then holds true when it comes to the market, what about the market needs? I'm quite skeptical. I want to also address your previous question or statement. I cannot imagine that people just wear clothes even though the color is not good, just because they can say, yes, this is directly recycled. So they won't accept that. So we need to find ways to get the same quality to the fibers. So that actually we have to be very aware that the people's wish is addressed in all kinds of modifications. But there are ways. You're right. For example, when you address the recycling of the colors together with the polymer, the cellulose, for example, fibers, then we need to assure that if there is a change in the color, that we compensate for this change. And there are also thoughts how to do that.
How about Michael and Pirjo? Do you have any further thoughts on this?
Well, I think from the two scenarios that you explained, they are not mutually exclusive. They complement each other. Like in many things, it's not that there is one master solution, but it's a smart mix of different things. And definitely we have to prolong the lifetime of our garments and use them longer. And then at the end, then we have to know what to do with them and keep them in the loop. And in that perspective, synthetic fibers are not bad. It's like how we handle them at the end of their life. This is what makes them bad in the common sense and creates the environmental impact that they have. But if we manage to keep them in the system, then they are excellent fibers.
Yes, very good. How about you, Pirjo?
Well, I'm kind of confident because during my lifetime, this thing has completely changed, meaning the seeing garments as an investment, becoming this all the way to this fast fashion. So I'm pretty confident that this can also, the change can happen again, meaning that of course we need to use all these assets that we have, all the tools we have, using them for a longer time, and then using all the material, recycling the material, and hopefully upcycling the material several times and so on. All those things will be needed. That's for sure. That's clear.
Yes, and I very much agree with both you, or all of you basically, and Mihail's point about many solutions being needed is definitely very true. The reason I was asking the question is because now when circular economy is so popular, there is a little bit of maybe the tendency, perhaps more with business, of seeing it as just let's have our materials circulating more, and then that's kind of the whole solution, and the longevity is more often forgotten because it's not so obvious business model in terms of the revenues as is the circulating everything and sticking in with the same let's sell more models. So it was good to hear your thoughts on this too. Finally, I would like to have your very let's say 10 euros worth of thoughts on the interdisciplinary work that you have now been doing, chem and arts, the design from arts, for nearly 10 years. Could you give some idea of maybe the main lesson learned, or maybe the main valuable thing that you think that has come out of it in this specific arena of sustainable textiles from the future? And this is again a question to all panelists. Herbert, yeah.
Okay, again me. Yeah, of course, coming from a completely different world, I was totally fascinated from this nice collaboration across the different schools, the collaboration across the different disciplines. And I can only assure that this is a role model for all universities to find possibilities to collaborate on topics which have a big societal impact. And the textile development has this societal impact, but there are many others. And we see that this collaboration across the different disciplines and schools has already continued with other in other areas of research, rare earth metals, for example, and others. So this is the future, absolutely, I fully agree. The thing is that the organization at the university is a little bit behind. So we need to find solutions to also allow the official PhDs or activities, educational activities across the different disciplines.
Yes. Mihail, Pirjo, what would you not have learned without this collaboration? What would you not know?
I would not know anything of these, really these kind of research-based issues that, for example, Herbert and Michael have been opening up. And personally, I have to say that this journey has been extremely inspiring, extremely also informative. So I'm really looking forward to find new ways and to continue this kind of collaborations and expand them between disciplines. It's not easy. It's not easy at all. So maybe I have learned many things, but also there are still many things to be learned. The language is one thing. Sometimes we talk of the same thing or use the same word, but talk of the different things, like example, biomaterials. So if you ask from a person from different disciplines, what does it mean? You get different answers.
Yes, thank you. Thank you, Pirjo. Mihail, if you want to add anything, you are free to do so, but if you think that they've said all, then We
Absolutely.
will.
Nothing to add to that anymore.
Okay. I can see that there are some comments in the chat. I don't see direct question except for a question on a collection system for textiles, which is going to happen soon. There is new law upcoming and a lot of activities around that in EU 2025. Finland is trying to have the law and system in place in 2023. So much is happening. At this point, I would like to thank all participants for the excellent questions and comments, and especially thank our great speakers. I think that this has been super informative session, and at one point we actually had over 130 participants, so that I think was a record in the history of Aalto Sustainability Talks. So thank you very much for joining us, and if there is anyone who still wants to ask a question from Michael, Herbert or Pirjo directly, we can keep the line open for a couple of minutes. But officially, let me wish you a very nice day, and do follow Aalto Sustainability and Aalto Sustainability Talks series, which will continue in the fall. Bye-bye, and thank you again.